Hi guys, I am making attempt 4 at this video. I'm sorry it has taken me so long to get it posted. Hopefully this time it will work and I won't have to make it again. So this week we've been talking about the scale of the solar system. So I showed you a picture of the Earth and we compared it to the size of the moon being a quarter, but the two were 3 meters apart. We talked about the sun being 7 inches, like a small pizza, and the earth being a teeny tiny speck almost, but then being 65 feet apart at that scale. So I want to give you another opportunity to see the comparison in size of some other objects in our solar system. So I'm going to make a 3-dimensional model of the sizes of our 8 planets using Play-Doh. So this is approximately 5 jars of Play-Doh, and I have stretched it into a stick here of about 30 inches. Now it's hard for you to see because if I have the ruler here, it looks a little bit small. If I have the ruler here, it looks a little bit big, but I promise here in real life, this is 30 centimeters. I'll give it a little stretch, it's a little short, 30 centimeters. And so the first thing I need to do is to break this down into tenths. So I'm going to section it off into 10 equal sections, 30 centimeters, 10 equal sections, each will be 30 centimeters. So 3, 6, 9, 12, 15, 18, 21, 24, 27. All right, and then 30, 10 equal sections. Now I'm going to count off 6. 1, 2, 3, 4, 5, 6. These 6 sections, 60% of our Play-Doh is going to become Jupiter, the largest planet in our solar system. So 60% of the volume of our planets is made up by Jupiter. But I don't want you to think about it as being a heavy planet. It's not going to weigh as much as 60% of our solar system. It's talking about volume, which is the space it takes up. Jupiter is actually a gas giant. It's made mostly of gas. So although it does have a dense core that attracts that gas to it, its overall density is very low. So Jupiter would float in a bathtub. So if we put this on our paper here, labeled Jupiter, you're going to be able to see the size of this planet and compare it to our other planets that we're going to make. So that was Jupiter. Now, the next 3 sections, 1, 2, 3, we're going to separate those off. And these are going to become part Saturn. Now, it's not all of Saturn. Saturn's going to get bigger. But for now, we've got Jupiter. I don't want to have that crack sticking up there. There we go. Jupiter and part of Saturn. And now we have left 1/10, 10% of the Play-Doh that we started with. And this is what we're going to use to make the rest of our planets, 6 and a little bit of Saturn. So to do this, I need to roll it out into 30 centimeters long. So I'm not going to make you watch me do that. I'm going to give you a pause. All right, 30 centimeters. So we've taken 1/10 or 10% of our original volume and we've separated it out and we're going to break it into tenths. So again, 3, 6, 9, 12, 15, 18, 21, 24, 27, and 30. So of these 10 pieces, 5 of them, 1, 2, 3, 4, 5, are going to join our Saturn pile, but we're not done. We're going to take these 2 and these 2, and these are going to become Neptune and Uranus. So they are very, very similar in size. Also gas giants, so large, but not nearly so large as Jupiter. So Neptune, and then one more, roll this one up. This will be, keep it, I like it look kind of round. This one is going to be Uranus. So you can see they're just about the same size, but much, much smaller than Jupiter and Saturn. We're still working on him. So we've got this one segment left. This needs to be rolled out again. I've got to roll this into 10 centimeters. So let's roll that again. All right, this has been divided, this has been rolled out to 10 centimeters. We want to divide this into tenths. This time, each tenth will be 1 centimeter. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Now, we're going to take 9 of these, and they're going to go be part of Saturn. So now we finally have all of Saturn. Let's roll it up. So notice what we have left. We took our original amount, took 1/10 of it and rolled it out. We cut most of that away, took 1/10 of it and rolled that out. And now we've got 1/10 of that amount left. So if I've done my math right, we had a tenth, a 100th, and then a 1,000th. So we are down to 1,000th of the volume of our solar system, the space taken up by the planets, and we have only made half the planets. So we've got Jupiter, Saturn, Neptune, Uranus. We still need Earth, Venus, Mars, and Mercury. And this is what we've got. So the next thing we're supposed to do is divide this piece in half. So let's get this piece into a size that we can divide in half. So just about there. Does that look like 2 even pieces pretty much? All right. This half is going to be Earth. This is us. So this little piece of Play-Doh right here is us. We are so much smaller than Jupiter. Jupiter is huge compared to us. And now we've got this much left. This is for our last 3 planets. So I've got to roll this piece out to 10 centimeters. So that'll take me a little bit of time because it's tiny. Okay, 10 centimeters. Now it's going to ask us to break this down into tenths again. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And this 9/10 is going to be Venus. So Venus is almost the same size as Earth. So back over here, there is Venus. We have 2 planets left, and we have this much Play-Doh. Now, I'm supposed to roll this out to 2 centimeters. Think I can do it? All right, 2 centimeters left. Now, it says to measure off 2 millimeters of those 2 centimeters. That is Mercury, and this is going to be Mars. So let's roll those up into a tiny little ball. We've got our planets now. We have Mars and Mercury. Hopefully you'll be able to see it right there. All right, here are our 8 planets. All right, so I wanted you to be able to see them. We have Uranus and Neptune, the farthest 2 planets, approximately the same size right here. We have Jupiter, our largest planet, but first, comes Saturn. Now Saturn has rings. Those are not included in this diameter. This is just the diameter of the central planet. Then we have Mars is next on the list before Earth, Venus, and tiny Mercury closest to the sun. Now, I did not make the sun because I cannot afford to make the sun. A ball of Play-Doh that was big enough to be the sun would be 3/4 of a meter in diameter. So a huge ball of Play-Doh. It would be hundreds of pounds of Play-Doh. I walked out with my students in the hallway to show how far these planets would be apart. It's hard for me to do that with you guys, but we are talking about to get the orbit of the inner planets. We had to walk almost down from one end of the school to the other end before, from the 7th grade hallway all the way down to almost the beginning of the 6th grade hallway. These planets, even on this tiny scale, to march out their accurate distance from the sun to them is an incredibly long way. And I'm going to try to figure out a way to show it to you, but my first attempt at a video didn't work, and you know how my videos are going, so I'm going to leave it at this.